Now we have to find the ratio of reactants and products involved in the reaction and show how these can be used to produce the balanced simple equation for the decomposition of sodium nitrate. So by the end of this question, we must balance the chemical equation for this decomposition reaction. We are given the relative atomic masses of sodium, nitrogen, and oxygen. Let's start with writing the chemical equation. Sodium nitrate NaNO3 will produce sodium nitrite NaNO2 plus O2 oxygen gas. Please pay attention. This isn't the balanced equation. How can we check if it's balanced or not? Simply let's count the number of oxygen atoms. On the reactant side we have 3, whereas on the product side we have 4. 2 plus 2 is 4. So this isn't the balanced equation. We have to balance this equation by the end of this question. Let's write down the masses of the reactants and the products in this reaction. So the mass of sodium nitrate is 8.5 grams, that of sodium nitrite is 6.9 grams, and the mass of oxygen that we have just calculated is 1.6 grams. To find the ratio of reactants and the products, we must use the number of moles. So we need to find the number of moles of these. What's the relation between the number of moles and mass? Excellent. The number of moles is equal to the mass divided by the relative atomic mass or by the formula mass. So we know the mass and we need to find the number of moles. Can we find the relative atomic mass or the formula mass? Of course we can. Let's start with sodium nitrate, NaNO3. The relative formula mass of sodium nitrate is the relative atomic mass of sodium plus the relative atomic mass of nitrogen plus 3 times the relative atomic mass of oxygen because we have 3 oxygen atoms. So we will add up the relative atomic masses of all atoms present in this compound. So that's 23 plus 14 plus 3 times 16, which is equal to 85. Please pay attention if you have more than one atom of the same kind. So here we have 3 oxygen atoms. We have to multiply by 3. Try now to calculate the relative formula mass of sodium nitrite. Let's do this together. The relative atomic mass of Na, sodium, is 23, plus the relative atomic mass of nitrogen, which is 14, plus 2 times 16, because we have 2 oxygen atoms, and the relative atomic mass of each oxygen atom is 16, and this is a total of 69. Now we will calculate the relative molecular mass of O2. So 2 times 16, which is equal to 32. So these are the relative formula masses of each reactant and the product. Now we have the mass and the relative formula mass. We can calculate the number of moles. How to calculate the number of moles? As the rule over here shows, we have to divide the mass by the relative formula mass. So in case of sodium nitrate, we will divide 8.5 by 85. So the number of moles will be 0.1 for sodium nitrate, 0.1 for sodium nitrite, and 0.05 for oxygen gas. Now let's find the ratio. We will divide the ratio by the smallest number. So 0.1 divided by 0.05 is 2. For sodium nitrite, 0.1 divided by 0.05 is 2 as well. And for oxygen, 0.05 divided by 0.05 is equal to 1. So the simplest ratio will be 2, 2, and 1. So for every 1 mole of oxygen gas to be produced, 2 moles of sodium nitrite will be produced, and 2 moles of sodium nitrate will react. So this is the simplest ratio. And thus, the balanced equation for this reaction is 2NaNO3 will produce 2NaNO2 plus O2. When we don't write the number over here, this means that it's equal to 1. So this is how we will use the masses of reactants and products to balance a chemical equation.